Okay, so on note 7.4, we're going to be solving systems of inequalities. Whenever you're wanting to solve a system of inequalities, you're trying to find all the points that they have in common. So you'll be shading, and then you'll look at where they're both shaded or all three of them are shaded. Okay, so we're going to start out with example 1. We have two different, if you notice, both of them will be quadratics, so two different parabolas that we're going to graph, and we're going to find the points that they have in common. So we're going to use the calculator. So the first one, I'm going to type in y equals negative x squared plus 4. And then I'm going to go ahead and go to the table, second graph, and I'm going to make a table on my paper so that way I can plot those points, or you can just look at the calculator and plot them. So negative 3, negative 5, negative 2, 0, negative 1, 3, 0, 4, 1, 3, 2, 0, and 3, negative 5. Now I'm going to go back to y equals, and I'm going to type in the second one, x squared minus 2x minus 3. And if you wanted, you could type both of them in y1, y2, and look at the table at the same time. Okay, so this one, so negative 2, 5, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0, and 4, 5. Alright, so I'm going to start with this first quadratic that we have. Negative 3, negative 5, negative 2, 0, negative 1, 3, 0, 4, 1, 3, 2, 0, and 3, negative 5. So that's symmetrical. Notice that your vertex is your 0, 4 point. Okay, before you connect your points, you need to look at your inequality. It says less than or equal to. If it says equal to, you would have a solid line. If y is by itself, which we have on both of these, any less than that you have, you're going to shade below the parabola. Any greater than, you're going to shade above. So notice this is less than, so we're going to shade below. So we're going to have a solid line. Now, just like before when we were looking at linear systems, we waited to shade until the end to see where they were both shaded. So I'm just going to draw some arrows here so I know that it would be below the parabola. How you can tell is go to any point on the parabola and go below it, and then that's where you need a shade. Okay, so now I'm going to look at my second one, plot those points, negative 2, positive 5, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0, and 4, 5. Now before you connect your points, again, look at your inequality. Notice that it says greater than. It's not equal to, which means it will be a dotted line. And since it says y is greater than, you're going to shade above the parabola. So I'm going to have dotted this time. And we're shading above. So go to any point on your parabola and you would shade above that point. Okay? So we're trying to find the points that they have in common. So your system would be, or your solution would be this section here. So any point in that shaded area, if you were to plug into both of your inequalities, it should be true for both. If it was on the blue line, it wouldn't be because it's dotted, but on the pink line in that shaded area above the blue line, it should be true. So that is your solution, wherever they have the points in common, so your double shaded area. Notice on example 2, we have 3 of them. So I'm going to start with the first one. So we have x squared minus 5. I'm going to go to the table. Negative 3, 4. Negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, 2, negative 1, and 3, 4. Type it in the second one, 2x squared minus 4. That's negative 2, 4, negative 1, negative 2, 0, negative 4, 1, negative 2, 2, 4, and those are the only ones that we can plot in the graph. Okay, and then this last one here, notice that it's just y is less than or equal to 4. If you do not have an x, that means your slope is 0. Which means a horizontal line. And it crosses the y at 4. So your y-intercept would be 4. Okay, if you had plugged it into y equals, just typed in 4. If you went to the table, every single y value would be 4, therefore it's a horizontal line. Okay, so let's start graphing them. We'll start with the first one. So we have negative 3, positive 4, negative 2, negative 1, negative 1, negative 4, 0, negative 5, 1, negative 4, 2, negative 1, and 3, 4. Before you connect your points, again, you need to look and see if it would be solid or a dotted line. So notice here, it says greater than or equal to, so it will be solid, and we will shade above the line. Make sure you extend it throughout your graph there. And we would be shading above, so pick a point and go above it. Okay, so looking at the second one, we have negative 2, positive 4, negative 1, negative 2, 0, negative 4, 1, negative 2, and 2, 4. Your inequality, less than or equal, so it would be solid, and we'll shade below it. So just pick a point and go below it. And then this last one, it's a horizontal line. Notice that it says less than or equal to, so it's solid, and we would shade below the line. It's a horizontal line. It crosses the y at 4. And we would Okay, so we're trying to find where all three of them are shaded. So we're trying to solve the system, finding all the points that they have in common. Okay, so the green was below, the purple was above, and then the blue was below. So it would be this section here. So you can plug any point in between or where that shaded area is, and it should be true for all three of them. Okay, notice on example 3, we don't have y by itself, so that's what you're going to have to do first on both of them if you're going to use the calculator to graph them. So y would be less than or equal to negative x squared plus 5. If we get y by itself on the second one, we'll add 5x squared. Okay, so we're going to type those in. Let me show you what it looks like whenever you type in both of them. You want to do it all at the same time. Y1 is your first one, Y2 is your second one that you plugged in. So I'm going to look at this first one. We'll go -3, -4, -2, 1, -1, 4, 0, 5, 1, 4, 2, 1, and 3, -4. Now when you're looking at your second one, we're using these x values and then the y2 y values. Okay? So -2, 9, -1, 6, 0, 5, 1, 6, and 2, 9. Okay, so let's graph the first one. -3, -4, -2, 1, -1, 4, 0, 5, 1, 4, 2, 1, and 3, -4. Before you connect the points, look back at your inequality. It's less than or equal, so it's solid, and we're shading below the line. Make sure you extend it throughout the graph. Below the line, pick any point, and you'll be shading below it. Okay, so then the next one, we had -2, +9, -1, 6, 0, 5, 1, 6, and 2, 9. Again, check your inequality. It's greater than or equal to, so you would have a solid and you would shade above. Okay, so notice this purple one we would shade below, the blue one we would shade above. Notice they don't have any shading that's the same, okay? But they do have a point in common. That's the only point they do have in common, because there's not a double shaded area there. So your solution, you actually have to write your solution here. Your solution would only be one point, and that point is 0, 5. That's the only point that they have in common. Okay, last one. First one, we need to get y by itself in order to use the calculator and plug it in. So we're going to subtract x. So y is going to be less than or equal to -x plus And then the next one, we're getting y by itself, so use a different color. Add 4x squared. Put it in standard form. So x squared first, then x, and then your constant. And then notice I still have a 2 in front of the y, so I need to divide everything by 2. Okay, I'm going to type in negative x plus 6. Notice this isn't going to be a parabola because it's linear. It's going to be a straight line. And then you have 2x squared plus x minus 3. So you can type them in at the same time if you want, but if it confuses you, then just type each one in. Alright, so looking at the first one, negative 3, 9, negative 2, 8. Negative 1, 7, 0, 6, 1, 5, 2, 4, 3, 3. So that's not going to be symmetrical there. Looking at the second one. So looking at your first column for the x's and then your second column because you plugged in the second one. So that's going to be negative 2, 3. Negative 1, negative 2, 0, negative 3, 1, 0, and 2, 7. Alright, so graphing the first one, negative 3, positive 9, negative 2, 8, negative 1, 7, 0, 6, 1, 5, and notice this is linear, so we could keep going. And look back at your inequalities. Less than or equal to, so it will be solid. If y is by itself and it's less than, you're shading below. Extend it throughout the whole graph, and then you would shade below here. Okay. The second one, we have negative 2, 3, negative 1, negative 2, 0, negative 3, 1, 0, and 2, 7. Look back at your inequality. It's solid. Everything greater would be above. So just pick any point and go above it. Alright, so notice on this one, the purple was below, the blue is above. So your double shaded area where they're both shaded, so what they have in common would be all of this section here. So you can check it by plugging in any point in between in that shaded area, and it should be true for both inequalities. So this is solving a system of inequalities dealing with, sometimes you have parabolas, sometimes you have a mixture of linear and quadratics.